Assalamualaikum. I'm M Safwan Ali from Electrical, and I am the sole member of my team, and I have the light tracking report, which I'm going to present in the group presentation in the control system and analysis. So let's start how it works. The basic principle is that the light tracking robot, it is a light tracking robot. When I put light on this LDR, this LDR tries to move in this position until the light intensity is equal. Similarly, if I put light on this LDR tries to move in this position until the light intensity is equal. Okay, it simulates the motor movement of the solar panel, which needs to be moved accurately and efficiently according to the sun position. If I this will be demonstrated later. Okay, in the starting, the motor will go to its starting position, and I also have implemented an LCD which displays group member and tells whether it's moving clockwise and anti-clockwise, and in the end it also tells how much degrees it has moved in the respective direction. So let's start. I am resetting the controller. As you can see, it says different things.
अल्लाह के बंदे उसी में से क्रॉप कर लेता तो भी अजीब ही है।
और नहीं, वो मसला नहीं, मैं एक और चीज़ करना है उसमें। The speed is different to demonstrate the different effects of pulse width modulation. To move the servo motor in the required direction, pulse width modulation is required of 1 millisecond and 3 milliseconds, respectively, in counter and clockwise directions. I have used different loop circles to demonstrate different speeds. It moves more slowly in clockwise direction than in an anti-clockwise direction, as it is evident from this. Thank you. Now I am going to explain some theoretical background of this project. In this project, we have used a servo motor. A servo motor is a special kind of motor which uses 3 wires for its operation. 2 wires for its power and 1 wire for a signal in the form of pulse width modulated signal. On the router of the motor, we have attached a disc. On this disc, there are 3 LDRs attached. LDR2 will be working as our sensing LDR, while the other 2 will be working as a reference or input LDRs. Whenever the LDR2's value becomes equal to either of the LDR, it causes the motor to stop rotation with the help of the attached controller. Okay, how pulse width modulated is used to control the motor. When we give a pulse with on signal for 1 millisecond and off signal for 20 milliseconds, the router moves from 0 degree to 180 degree in counterclockwise direction. Inversely, if we give a 3 millisecond on signal with a delay of 20 milliseconds, thus motor moves in clockwise direction from minus 180 degree to 0 degree centigrade, 0 degrees. However, if we give a pulse width of 2 milliseconds with a delay of 20 milliseconds, the router moves to 90 degree from either direction, from where it is. In this case, we have programmed our controller in such a way that if I put light on LDR3, it has more intensity and hence more voltage value, which is stored in a register. The LDR2 is moved in counterclockwise direction by given 1 millisecond pulse width and it moves until the LDR2's intensity is equal to LDR3's intensity. The torch is not moved, so when the intensity of LDR2 becomes equal to LDR3's, it stops. Similarly, opposite procedure is used for LDR1. Now, how LDRs are being used to detect the signal? Well, LDR is a light dependent resistance, and its resistance changes with light. When light is 3 on it, its resistance becomes very low, and it allows the currents to pass. Now we have used a variable resistance. Why we have used this resistance? Because if we do not use this resistance, all of the voltage appear on the LDR whether or not this resistance is high or not. So it cannot sense the voltage difference or voltage change by the change in light if we do not use a voltage divider circuit. Here variable resistance is used as a sensitivity controller and also for voltage divider for the voltage to be sensed. When light will be put on this LDR, more voltage will appear here, less voltage will appear here, and the ADC in the controller will detect corresponding values and store in the register assigned to this LDR. In this way, the LDR3 value is stored or LDR1 value is stored, and LDR2 continues to move to the idle location until its value becomes equal. Now, the main reason for the project, that is to implement a feedback system. How in this control system we have implemented a feedback control system. Here let me help you. As you can see, LDR1 and LDR3 are working as inputs, and when I put torch on any one of these two, the input goes to the controller. The controller orders the rotation control, that is the motor, to rotate in either LDR1's direction or LDR3's direction. On this rotation control manual, we have LDR2, which senses light intensity on each of its rotation. Here you can see that the output is being sent to the LCD, but a feedback is taken from here and subtracted from the input. Now LDR2 value is being continuously subtracted from the input until both equal 0. When both equal 0, rotation stops and the result is displayed on the LCD. Otherwise, it continues to rotate. Hence, a closed loop feedback system has been implemented in this project. Thank you.